most welcome to our lesson, our GCSE class. Okay, today, so we're looking at the edexcel GCSE paper. Basically, just jump up to check everything's okay. We're looking at the paper 1, non-calculator for the higher tier, and this is the Pixl version of the paper. Pixl live mock paper, 1 hour 45 minutes. Okay? So let's get started. That's nice. That's better. Okay, folks. Question number 1. Bismillahirrahmanirrahim. Usma, I'm spelling Usma, wants to find out the method of transport people use to travel to a shopping centre. Design a suitable data collection sheet. So there's no question as such involved. So design a suitable data collection sheet. She could use to collect this information. So we need to have, normally when we do one of these, how many columns do we normally have? 3 columns. First one's going to be the data that you're actually collecting. So what's going to be the data that we're collecting here? Any suggestion on the data that we're going to be collecting? Type of transport. Type of transport. Okay, now, she's going to ask the people, so that whichever one they're going to fit into, what is going to be a primary way of recording the results? The easiest. So we're going to have a tally. Okay. Sounds similar to tally, but that's something quite different. Okay. We have tally, and then after tally, after we got all our tallies done, what do we need to do next? We need to have a frequency which will summarize all the data values for us. Now, since we are here, type of transport, what kind of transport could it be? Car.
Bus.
Train.
Bus.
Taxi.
Train.
Biking,
Taxi.
cycle. And
Yeah.
walk.
Bicycle.
Plane.
Whoa!
Ferry.
You must have some rich friends or family members that come
Ferry.
to.
Ferry. So yacht. Just to go to.
Okay, that will do for us for the moment. Thank you, folks, for your suggestions. The suggestions are getting wild. Okay, let's move on to the next question. Question number 2. Okay, Fira. Sorry, Ifra. Okay, it's not too bright. Lovely. Okay, question number 2. That's also mine. Question number 2 says this conversion graph can be used to change between meters and feet. Use the conversion graph to change 6 meters to feet. So 6 meters, so meters along the bottom. Get our ruler. Okay, I think I'm a bit more clear on this. It's not very clear, is it? 2 to 4, 6. Folks, is it 10 little squares in it?
Yeah. Yeah.
I'm trying to find exactly where it is, because it's not, this would be a dark line there. That one there. So draw a line straight up. So we're starting at 6 meters. We hit the graph, and then from there we go straight across. Okay, use the graph to convert between 6 meters to 6 feet. So I am getting, according to my calculation, okay, what question? Question 2A. Now, I'm getting just under 20 meters, 20 feet, sorry. So I would say that's 15, 16, 17, about 19 and a half. So my answer for that one would be about 19.5 feet. Take into consideration that each one of these lines is worth 1 feet. And I'm in between 19 and 20.
119 is
19 is fine as well. So the mark scheme allows you any answer between 19 and even 21. Okay? That's all like, okay. Anything between 19 and 21 is acceptable according to the mark scheme. Okay, ladies, right, next question. Use the conversion graph to change 8 feet to meters. So 8 feet to meters. 8 feet is on this side, 5, 6, 7, 8. Okay. So now I'm going to change color now. I'm not going to change color myself, physically that's a bit difficult. Okay, and then we're going to go across and then come down.
2.25.
Okay, so what are we getting here? So we got here 0, 1. So it's, 1 is worth 5 squares, isn't it? Yeah, so that's 2, 2.2, 2.4, about 2.5. About 2.5.
So I got 2.4.
Okay, anything between 2.3 to 2.5 is acceptable.
I got 2.4.
Okay, so I'm going to have 2.2. Mine is just slightly. Wait for a second. Yes, it is. Yes, mine is slightly off 2 point. Okay, so do that one again. Okay, welcome, sir. 5, 6. Both calculations. 5, 6. Was it 8? 5, 6, 7, 8. 7, 8. There, just over. Okay. So 2.4 is a brilliant answer. Mine is just a bit more than 2.4 because there's 2, 2.2, 2.4. Mine's about 2. Actually, very close to 2.5. I'm going to go for 2.4 as well, actually. So my line is actually very, very close to 2.4. So anything between 2.3 and 2.5 is acceptable. Okay. So if I wanted to be very accurate according to my calculation, I would probably be about 2.42 or something. That will do as an answer. Anything between those values. Okay, next question. Robert jumps 4 meters, James jumps 12 feet. Who jumps furthest, Robert or James? How did you get your answer? So we got 4 meters and we got 12 feet. So what we need to do, we need to use the conversion graph to work that out. Okay, now 12 feet. Okay, 12 feet would be, what have we just worked out? How many feet? 8. Okay, but where's 12 feet? So that's 8, 9, 10, 11, 12. Okay, folks, has everybody gone across on 12?
Mm-hmm.
Okay, and what did you get, madam? We getting around about 2, 3, 3.2, 3.4, 3.6. About 3.62. 3.62 meters. And the question says here, the other person jumped 4 meters. So if one is 3.62 meters and another one is 4 meters, which one is the furthest? Is it Robert or James?
Robert.
Robert. So we can say for that one, Robert jumped the furthest, and Robert jumped because his was 4 meters, whereas what's the other person's name? Whereas James jumped approximately 3.62 meters.
So what was James?
So James jumped only 3.62 meters. In brackets, 12 feet. Okay, done. That's that question now. Right. Are we happy with that now? Ready for the next question? Right. Just open the door. Yes, after now. Should we move on to the next question now? Right. Question number 3 with a little star next to it. Mrs. White wants to buy a new washing machine. 3 shops sell the washing machine she wants. Clean machines, electrics and wash and go. He says so washing machines is buy now, pay later, £50 deposit plus 10 equal payments of that. Washing machine shop electrics will cost quarter of the usual price of £420. Wash and go is £280 plus VAT. Mrs. White wants to buy the cheapest one. She decides to buy her washing machine from one of these 3 shops. So we need to work out what the prices are. Okay, put your hands up if you've already done the prices and you've worked them at home. Saf, please put your hands up quickly if you've done it already at home. Tried it. Oh, nobody else, you've just done it. Mr. Hamza, have you done it? No? Okay, Mr. Have you done that? You've done the paper at home? Yes, but you left the paper at home. Okay, let's work it out. So washing machine, buy now, pay later, £50 deposit plus that. Now, 10 equal payments of £27 will give us what?
220.
10 pound by 27 will give us?
270.
270. And you have to pay a £50 deposit. Remember, it's this and 10 equal payments. Okay? So what does that give us all together?
320.
320.
Okay. This one is a quarter of the usual price of 420. So 420, we have to divide it by 2 and then divide it by 2 again. So quickly we're working out divided by 4. So 420, half of 420 is 210 and half of 210 is
105.
105. Okay, so 105 is how much you save. So that's how much, that's a quarter of this. And we have to say it's quarter of means minus it. So 420 minus 105 will give us 315.
315. I don't know. Just
315 is good. That's 320, that's 315. This one's 280 plus VAT at 17.5%. VAT now is 20%. So you tell this paper has been written before the VAT was changed. Okay, now 280 plus VAT. Now, if you have to work out 17.5% of 280 without a calculator, most students will be looking for the exit. Literally. Doesn't need to be that way. Now 17.5%, if we break this number down, it comes into nice little chunks that we can easily work out. 17.5% is made up of
10%.
and then
5.
and then
2%.
2.5.
Oh yeah.
Okay, so 17.5% can be divided into 3 nice easy chunks. Remember, this is non-calculated paper. This is non-calculated paper. So you can't use calculator on it. You have to use the calculator that God gave you when you were born. That's called the brain. Okay, now we've got to work out 10% of 280. Working at 10% of 280, folks, it's like a gift. It's like Eid, happy day. So 10% of 280. How do we work at 10% of 280? What do we do? Easy technique. 10% is 1/10. So we divide by 10. 280 divided by 10 is
28.
28. Now, if you know what 10% is, how do you get from 10% to 5%? We halve it, divide by 2. So if I halve the percentage, I halve this. So 28% divided by 2 will give us 14 pound. Okay. Now, if you know what 5% is, you can work out 2.5% by halving again. So 14 divided by 2 is 7. Okay, now what I'm going to do now, okay, I'm going to rub this off here, just make it a bit more clear on this side, so we don't have all the jumps on there. Get rid of these for the moment. 10% is 28, 5% is 14, 2.5% is 7. What do you have to do to work out 17.5%? We have to just simply add them all up. So 8 add 4 is 12, 12 add another 7 is 19. 2 add 1 is 3, 3 add 1 is 4. So this machine here is going to cost us 280 plus another £49 worth of VAT. So that gives us a total of. Okay. Mrs. White wants to buy the cheapest one. So where does she buy it from? She buys it from electrics, and the cost is. That's the answer that you get right at the end. Mrs. Reese, you got that right? You happy with that? Okay, Ifra, did you, Afida, did you do that question at home? You tried?
I mean,
No?
yeah.
Huh?
One here.
She wasn't here last
You
week.
guys were tripping last week as well. Okay. Are we happy with the answer? Saf, you got that? All of it? Got the same good answer?
Yeah.
Happy with that? Okay, ladies, can I have a back now? I don't know if you got all that. Those of you who got the exam in about a week, 2 weeks time, you guys should be on the ball with this stuff. This stuff should be, oh, as I say, a walk in the park. Okay, question number 4. I've just, you said expand. I've actually expanded the picture as well and made it bigger. It says expand. Expanded it. Expand these brackets. Okay. Double brackets. Start from the first element, x. Multiply by each in the second part, yeah? Each element second part. So we have x times by x will give us x squared. X times by plus 3 will give us plus 3x. We have plus 2 times by x now will give us, and plus 2 times by plus 3 will give us plus 6. Okay, now what do you get for that, Umar? What was the simplified answer?
X squared plus 5x plus 6.
X squared plus 5x plus 6 is beautiful answer. Lovely. Thank you. Okay. Mr. Safi, you get that as well? Right, good. Factorize 5x minus 10y now. So 5x minus 10y, we're going to use common factors technique. Okay, Ifra, can we pay attention please? So we have 5 times by x, split that up into factors, minus 5 times by y times by 2. Okay, it's the same thing as saying 5 times by 2 times y, it's just written in different order. Just test it, see what you guys are making. Now, what is the highest common factor? Is?
5.
Only 5, yeah. So nothing else is common. So you pull the 5 out. And we're left with x gets copied down, minus gets copied down, and y times by 2 is 2y is better written that way around. 2y done.
You got 9 seconds left of the video.
Oh, that's good. Is that the end of that question?
Yeah. No, there's another part to it. 3.
Okay, well we have to stop there because the video stops there. So, this part of the question got cut out from the last part of the video because we ran out of seconds. Okay, question 4b. Okay. Can you pass the keys back just in case you forget and take them home?
Can catch.
Yeah. Thank you. Question 4b. Factorize fully. Factorize and fully. Now, we're going to do the same way. We're going to split these letters and numbers up into all the factors. So 3pq is the same as saying 3 times by p times by q. And the time I'm going to write it in blue. Okay. Minus. Now 12. What will the 12 split up into? Taking into consideration we have 3 here.
4, 3, pp.
Good. 4. Oops, wrong color. 4 times by 3 times by p times by p. P squared is p times by p. 12 is 4 times by 3. Over here. Okay, right. And let's keep the theme running the same. The multipliers are in blue, so they show a bit more clearly in the video. Okay, are we happy with that so far, everybody? Yeah? And the highest common factor this time is? 3p. The highest common factor is 3p. So what we're going to do with the 3p's, we pull the 3p out over here, outside the brackets. And what do we put inside the brackets? whatever is left over, which is Q and the minus and the
4p.
4p. Finish. So it should be 3p outside the bracket, Q minus 4p inside the bracket. Okay, so you got that right?
Yeah.
Happy with that? Good. Okay, next question. Whoa, that's a bit too big. A mouse gone. There we go. Right. Good. Okay, this question is question 5. Go draw an ordered, keyword is ordered, stem and leaf diagram for these heights. Now how many data items do we have in this question? 20 data items. Okay, now we look at the beginning 7, 8, 9s and 10s. So 70s, 80s, 90s and 100s. Do you have any 60s?
No.
Okay. Now it's important that you put a key down. So we can start off over here on the side. Is that number? So a small key saying that 7-3 means 73 centimeters. You must put a key down in your stem and leaf diagram. Okay, let's have a look at the 70s now. All the numbers in the 70s. So let's make sure we got 73, 1, that one. Yes. Okay, which number goes first then?
71.
Then?
73.
And then?
78.
78. Let's cross them out so we don't use them again. Okay, the next one we're going to use is 80s. Okay, Mr. Umar, how many 80s do we have? 1, 2, 3, 4, 5. Okay, now the 80s, what's the smallest 80? 81. And the next one is? 84. How many times 84? Twice, you write down twice. And then we have? 87 and 80. Try to keep your numbers spaced out in the proper spacing. Okay, right, you can cross all those out now. You don't need those anymore. Okay, that's done. Right, what about the 90s? How many 90s do we have?
5, 6.
1, 2, 3, 4, 5, 6, 7, 8. Okay, come then, far away is the first number then. So 90 what first?
91.
91. And then we have 90?
2.
92, yeah? 92 and then?
93.
Okay, then?
96.
96 and then?
95. 95. 95.
95, okay, sorry, yeah, okay. 5, 6, another 6?
Yeah.
And then?
Number 6.
Another 6.
And then 8.
And then?
8.
8.
Yeah.
So done? Okay, so how many do you have there? 1, 2, 3, 4, 5, 6, 7, 8. Okay, and how many in the hundreds? We have 100, and then 101, and then 103 and 104.
Yeah.
Okay, let's just quickly check that we got all our 20 data values quickly. 1, 2, 3. So that's going to be 12, 13, 14, 15, 16, 17, 18, 19, 20. Hang on, 20 values, lovely. Okay, now they've got some questions on that. I'm not going to move that from the board now because I'm going to lose the information. Because work out the range. Okay, somebody tell me what the range is. Put your hand up if you know what the range is. Range, go on then.
33.
Okay, now I want to know what the range. How do you work it out, the range?
It is the largest number take away the smallest.
Okay, excellent. So the range is equal to the largest value minus the smallest value. Right, what is the largest value?
104.
104. 104, and then we minus now the smallest value, which is 71. And 104 minus 71 will give us an answer of 33. Excellent, good. Okay, what question are you at the moment?
5.
Yeah, question. Done. Okay, one more question. It goes, find the median height. Now we have 20 data values. Okay, they already are in order at the moment. Okay, now remember, when you have, just think of 20 data values as 20 friends. These are 20 friends of yours. Okay? And if you arrange 20 friends and you're supposed to find the middle friend, can you find a middle friend of 20? It won't be an extra friend, will it? Because you have 10 people this side and 10 people this side, yeah? So it'll be in between the 10th person and the 11th person. Similarly, in this data here, we have to look what number is halfway between the 10th value and the 11th value, because it's even number of values. So that's the first, second, third, fourth, fifth, sixth, seventh, eighth, 9th, 10th, 11th value. So we're looking for in between the 10th and 11th value, so it will be 92.5. So we can say that is our median. Okay, the median height is 92.5 centimeters. Okay, are we happy with that question, folks? All that? Okay, close the door slowly, please, yeah? Oh, no, it would be nice to give you that the bill for new door.
So where's Zishan?
Zishan, I have no idea. That's good. That's a good thing. We need to find out where Zishan is.
Should I predict it? You probably pick someone else. Text the right person.
Folks, conversation is recorded. Yeah? Come on. Yes, as I said, we'll keep it civil. Done that. Okay, let's make it a bit smaller. I don't want to spend the rest of my life editing the videos. Yeah? I've got better things to do in my life than be sitting down on a Saturday morning for 2 hours editing a 2 hours. Yeah, you try doing it. I can't wait at this time in the morning.
So you're going to have to edit this part now.
You reckon?
Indeed.
I'm just going to upload it. Let everybody have some fun on YouTube.
Nah, I'll take something.
Okay, here we go. Jenny's council has a target of 1/5 for households to recycle their waste. Straight away, we got all the different. We got fractions, we've got actual values, and we've got percentages. What percentage is 1/5? 1/5 is 20%. Yeah, because 20 divided by 5 is 100. Yeah? So 1/5, you should know that as a common percentage value is 20%. In January, Jenny recycled 1/10 of her household waste, which is how much percent? Which is below what she's expected to do. In February, she recycled 15 kilograms of her 120. So let's work out that percentage, yeah? To see whether she's on target or not. Because the question goes there, has Jenny met the council's target, which was her best month for recycling, and show clearly how you will take answers. So 1/5 is 20%, 1/10 is 10%. Okay, well, we should go show clearly how you got your answers. So let's do some maths now. So 1/5. I want to change it into a percentage. So I'm going to make it equivalent to 100ths. So we multiply the bottom by 20 and the top by 20. So 1/5 is equivalent to 20 over 100, which is 20% is the council target. Okay? Right, that's that value being converted into something that we can make sense of. The next value, in January. Let's change color now. January. So in January, she recycled 1/10. And 1/10, if you convert it into a percentage, multiply the bottom by 10 to give you 100. What you do to the bottom, you do to the top. So 10% in, was that January, yeah? So in January, she recycled 10%, and that was actually below the target. Okay, right. Right. Let's have a look at February. That's January. Let's do February now. We need to convert 15 kilograms out of 120 kilograms into a percentage. So we do 15 out of 120. Now to tell a normal fraction, I mean any type of fraction, these fractions I use the equivalent technique because 5 is a factor of 100 and I can easily convert from 500. 120 is not a factor of 100, so I'm not going to use this equivalent technique which I use here. I'm going to use the standard technique, I mean what you said, the traditional technique. So when we change a fraction into a percentage, we multiply it by 100 over 1. Now, how do we deal with that? So start. This is a fraction, and I'm going to convert this fraction into a percentage by multiplying by 100 over 1. How do we deal with this now, this fraction question? What do we do? What is the technique for this? We try to cancel. No, cross multiply, folks, you're thinking confusing. We cross simplify. You don't cross multiply. Cross multiply is when you have a formula like, and you take that up there and you bring that down here. That's called cross multiply. That's something completely different. Okay, I know it sounds nice, cross multiply. Okay, right. So we cancel diagonally. We divide 100 by 10 and 120 by 10. Okay. Now, can we do any more cancelling?
Yeah.
We can cancel this 12 with the 15 as well, can't we? So 12 divided by 3 is 4. 15 divided by 3 is 5. And the 4 and the 10, will they cancel? Yes. 4 divided by 2 is 2. And 10 divided by 2 is 5. So what we do is just cancelling and cancelling and cancelling until we can't cancel anymore. We're having like a little kind of a party of cancelling. Okay, now what we do here, what we got left on the top is 5 times by 5, which is 25 on the top. On the bottom we got 2 times by 1, which is 2. And then we got 25 divided by 2, which will give us 12.5%.
12.5.
Okay. And in March her percentage recycling was 13%. So now we've got all 3 months now. So let's just quickly write them down at the top of the summary. So January, February, and March. Okay, what was the total? What was the percentage for January? January, what was? What's the answer? How much did you recycle in January? 10%. And in February, how much did you do in February?
February
12.5.
12.5.
And in March, it was over here. It tells you that in March it was 13%. And what is the government target? 20%. The question says, has Jenny met the council's target? And the answer is way no. She's like, she's half the target, just a bit more than half, and just a bit more than that. So no, she hasn't. Answer is no. So Jenny hasn't met the, is it government or council target? Met the council target in any of her months. In any of the 3 months considered, or any of the 3 months. So that's our initial statement. No, Jenny hasn't met the council target in any of the 3 months. Rameez, are you okay on the timing and the video? Is nice and clean and clear and beautiful and lovely?
3 minutes left.
3 minutes left. Okay, we gotta finish this question off. Okay. Right. So we said first of all, then the question says here, which was her best month? So that's the second answer. Which one was her best month for recycling? March. So that's one part of the answer. Second part of the answer is March was.
Sir, can't you add March, like, was Jenny's good month onto the answer? Like.
You mean add these two up together?
No, like, add the answer to the second one to, like, put it all in one sentence.
You could, if you wanted to.
Wouldn't you lose marks?
No. I'm making, because they're asked 2 separate questions. I'll give them 2 separate answers. You could, no, Jenny hasn't met the council target in the 3 months, because that's actually a different statement altogether. So I'll give you as 2 separate answers, is better. So March was Jenny's best, how's the word? Best month for recycling. Because if you say best month, that's very vague. Best month for recycling. cycling. Lovely, done. So 2 separate answers there, folks, okay? We've got to do all the mathematics and show them. Show clearly how you got your answers. I've even showed how I converted that as well. I've showed everything. So you got no chance to lose any marks there. So don't assume anything, or don't assume 1/10 is 10%. Where did that 10% come from? So I've shown that 1/10, I've done this calculation and I got 10%. 1/5, I've done this calculation, I got 20%, and so on. Okay, everything is calculated as well. Right, we're coming to the end of this video length of 20, I think 18 point something minutes. I think this is a good place to stop this particular video, move on to the next question on the next video. So it's question number 6. Right, the next video is on question number 7. So, yeah, if we can start the video now if you want to, everybody's next to it. Then we can start a new question on a new video. Rameez, you can just press the red button on the back. Bismillah. Okay, folks, welcome back to the next video. Question number 7. It says ABC. ABC is an isosceles triangle that's indicated similar by these 2 lines here and these 2 lines there to indicate that these 2 lengths here are equal. Work at the sides of the angle marked X. Give reasons for your answer. So we've got to work out this angle here. In order to work out this angle, we first of all need to work out that angle. When we know that one, we also know that one. So, first of all, can somebody give me the mathematical definition for the situation that we have here? 360 is a part of the definition. How do we define it nicely, more clearly?
Angles around a point equal to 2.
We say angles
On a point.
at a point. That's it, not on the line, at a point. Okay. Add up to 360. So here's our point. So we've got this angle here, and then followed by that one, followed by this one, followed by that one. All of these together add up to 360. So that's our first bit of mathematics, that's our first bit of explanation. Now what we need to do, we need to add them up and minus them 360. So we're going to do now 360 degrees minus 160 minus 30, and minus one here is minus 90. Okay, what do we get for that? What do we get? 80. 80 degrees. Okay. Good. Now if this angle is 80, that means that this angle is also
80.
Okay, and how do we define that? So we can say here
I'm going to use that isosceles.
ABC. Angle ABC is equal to angle ACB. Is equal to 80 degrees because of the isosceles. That's the second bit of mathematics. Next part. Okay, now we've got to work out X. What do these 3 angles add up to? 180. So this one, and that one add up to 180. So we can say here, angle sum of triangle ABC is 180 degrees. So we can make a statement now. 80 add X is equal to 180. So that will give us 160. Add X is equal to 180. So X is equal to 20 degrees. 160 add 20 is 180. Are you happy with that? Okay, we got all that down. Make sure that you got the explanation down. It's not just a matter of having 20 degrees at the end. Because the question says that give reasons for your answer. First reason, mathematics. Second reason, with the statement over here, 80. Third reason, more mathematics. So you got to give reasons as well, okay? Make sure you explain it properly.
So don't rub the bottom off, please.
Okay. So move the question up.
No, you can't.
Okay, lovely. Question number 8. Here's a list of ingredients needed to make 12 scones. 220 grams self-raising flour, 40 grams butter, 150 milliliters milk, 2 tablespoons of sugar. Viv is making scones for 15 people. She's making 2 scones for each person. So she's making it for 15 people. But she's how many she's making each? How many scones is she making altogether? 30 scones. Okay, that's one way of writing that thing. Work out the amount of each ingredient she needs. So she needs to go from 12 scones to 30 scones. Okay. Yeah? Let's have a look. If you want to go from 12 to 30, let's just think how can you get from 12 to 30. We're going to go from 12 scones to 30 scones. Let's think of a technique.
Double and 6.
Okay. Without adding, in that sense. Remember, ratio is about multiplying and dividing. We can do adding as part of some of the calculation. But normally, let's think of it like this. If I want to get from 12 to 30, if I double it, then I'll have to add something. I don't do that. Let's go from 12 to 6. How do you go from 12 to 6? Okay, and how do you go from 6 to 30?
Time by 5.
Time by 5. So, if we want to go from the ingredient for 12 scones to the ingredient for 30 scones, what we can do on these numbers there, we can divide it by 2 and then times it by 5, and that will give us 13. That's one way of doing it. That's not the only way. Look at the amount of each ingredient she needs, so we can apply these 2 calculations to each one of these. So here we go. So we have here 220, divided by 2, times it by 5. Half of 220 is? Mr. Ramiz, are you getting this stuff down? 110. 110 times by 5 is 550 grams. The next one, 40 grams. 40 divided by 2 times by 5. What's 40 divided by 2?
80. Oh, sorry, 20.
40 divided by 2 is 20. 20 times by 5 is
100.
150 milliliters. What's 150 divided by 2?
75.
75 times by 5?
375.
75 times by 5, if you times it by 10, then divide it by 2. So you do 750, half of 750 will give you 375, yes? I didn't say your calculation was wrong, but you didn't show me how you've done it.
It's milliliters, not grams.
Okay, thank you very much. It's milk, milliliters, halib. Milk. 2 tablespoons of sugar or sukkar. Okay, 2 tablespoons, we do 2 divided by 2 times by 5. 2 divided by 2 times by 5 is?
5.
5 spoons of sugar. Done. The first one is the flour. The second one is the butter. And the third one is the milk. And the fourth one is the sugar, which is 5 spoons of sukkar. Done. Okay, are we happy with that question, folks? Okay. That's all done. Okay, Ifra, are you getting this down?
Yeah.
Taking into consideration that you weren't here, are you getting yours down as well, Afira?
Yeah.
Yeah?
Because you said it opposite.
Never mind. It doesn't matter, they know what I'm doing talking about. Right. Question number 9. Express 120 as a product of its prime factors. So 120 we divided by prime number 2. That gives us 60. Divided by the prime number 2 again. That gives us, we divided by 2 again, which is prime number. That gives us, now 15 won't divide by 2, will divide by 5 won't divide by 3, will divide by? 5. Remember, all of these numbers here are prime numbers. Stop when you get to 1. So 120 is equal to 2 times by 2 times by 2 times by 3 times by 5. And to simplify, we write like this: 2 cubed. So that's what it means by here product. Product means times of its prime factors. That means all these numbers are prime numbers. Okay, that one's done. Part B, find the highest common factor of 90 and 120. Well, we just worked out the factors of 120, haven't we? Now let's work them out for 90 as well. Okay, 90. So 90, will it divide by 2? To give us? 45, is that divided by 3? 5. That will give us? And then that will also divide by 3 to give us? 5. And that will divide by 5 gives 1. It doesn't matter which order you do these numbers in, you practice your numbers in the examination. Okay, so the factors of 90 are 2 times by 3 squared times by 5. Now when you go to the highest common factor, so these are the factors here. Ideally what we need to go back to these split up numbers rather than the indices. So for the moment, I'm going to rub these ones out here. I'm going to use the original. So that was the original 120 factors. This is the 90 factors over here. Now we're looking for the highest common factor. So we know 2 is a factor, is a factor. We know 3 is a factor, and we know 5 is a factor. So we got 2 times by 3 times by 5. 2 times by 3 times by 5 will give us an answer of
30.
30. Okay? 30 is the answer now. Okay, did you get that there?
Yeah.
Okay, everybody happy with that question? Right, question number 10, you can use this rule to work out the total charge for hiring a cement mixer. Total charge is £30 plus £7 for each hour. On Monday, Sally hired a cement mixer for 4 hours. Work out Sally's total charge. So we're going to start with £30. And we're going to add to that £7 for each day, for each hour that she hires it for. How many hours did she hire it for?
4.
4. So it's 30 plus 7 times by the hours. 30 plus 7 times by the hours. So that gives you 30 plus 28. 30 plus 28 will give us an answer of 58. Okay, and the next part of the question is, I don't really want to move it up now. We'll just read the next part of the question. The next part, part B says, on Tuesday Tom hired a cement mixer. Tom's total charge was £51. How many hours did he hire it for? So now they've given us the answer. So the total charge is £51. It starts off with £30 plus 7 times by the number of hours. So he got charged £51. We got to work out his hours. So what we need to do, we need to rearrange the equation and solve it for h. So we need to work out what this is. So the opposite, so h times by 7 is the first action, and then we add 30 is the second action. We move the second action first. So opposite add 30 is? So 51 minus 30 will give us? 21 is equal to 7h. Opposite of time by 7 is?
Divided by 7.
So 21 divided by 7 is?
3.
So the second part of the answer should be he hided for 3 hours. That's question number 10 done. Lovely. Okay, if you can get these kind of questions right, folks, and you can get to about 3/4 of the way through the paper, you're sorted. Even if you don't do the last quarter of the paper, if you get every single question right in the first 3/4 of the paper, let's just work it out here. You need to get an A. 66% roughly was the last year mark scheme for 2013. 66%. These grade boundaries do change from year to year, but 3/4 of paper, 75%. So you're way within there. Get everything right on all the easier questions. Okay? All the A-star questions are the last questions. So if you can attack and handle the first 3/4 of the paper, you're sorted. You got grade A in the bag. Okay, that's as long as the government don't get their fingers onto the grade boundaries and start changing anything too much. That's 2 parts of the question done. 108 times by 5 will give us 540 degrees, as Umar so eloquently said in the beginning. But I want you to, for all of us to arrive at 540 rather than just take it for granted. So 540, that's one way of working at 540. Or we can do this other technique. The number of sides minus 2, okay, times that by 180. How many sides do we have?
5.
5 minus 2 is?
3.
3 times by 180 is? 5. So that's another way of working at 540. So there's 2 ways. Using the external angle technique or using the internal angle technique. This is the internal angle sum. Okay. So we know that all of these angles must add up to 540. So, Mr. Ramiz, what do we do with these angles inside here? Let's add them up.
Yeah.
So 2x add 20. I'm going to start with this one here. Then I got 3x minus 30. Then I got 150 minus x. Put the minus x here. That way keep the numbers and the letters in the right place.
2x.
2x goes here.
2x.
And another 2x goes here. And then we add them all up.
It's 150.
150 here.
Don't minus 30 and 30.
Yeah, minus 30 here.
And add 20.
Yeah. I just set them out in column. So all the numbers are here and all the letters are here.
Oh.
So I'm doing the same thing you do, but you've done it a different way. You've written out this way. I've written out in columns. Okay, folks, let's work out now. You got 2x at 3x is 5x, like 1x is 4x at 2x is 6x at 2x is
10x. No, so check one please, I think.
Okay. It's 8x. 8x. So 150 plus 20, you should calculate again. 170 minus 30 is
140.
So when I add up all the angles inside, it should give us a total of
540.
540.
Yeah.
So all of this must be equal to 540. Now we need to work out the value of x. So
minus 140.
first action, second action.
You get 300.
So plus 140, opposite 140 is
Minus 140.
minus 140. Okay, 540 minus 140 is
300. 400 then?
that'll give us 400.
Oh, sorry.
I was just thinking that. So 8x is equal to 400. So opposite time by 8
Divide by
is divided by 8.
So you get a
I think the girls are a bit excited today.
Then the sugar.
They're a bit too excited. Okay, right, here we go. So x is equal to 400 divided by 8, which is equal to 50. So 50 is the correct answer for that question. It's not 40.
You missed that so.
Who missed that one? That one there?
Yeah.
It's over here. I'll show it here. So 150 minus x. 150 minus x. I'll show it back to front. Okay, folks, have you all got that done now, yeah? Smith, you got it done now?
Yeah.
Ifra
Yeah.
and Afira.
Yes.
Does any more get for this?
Yeah, you get some marks on that.
Thanks,
So when's the next break in about?
In about 20 minutes.
Really?
20.
You've only been having lesson for 35 minutes.
That's a lifetime thing that is.
What we can do next week, we just have a lesson for half an hour.
Yes, sir.
You come for half an hour and go home, you have the
Yeah.
Sunday break.
Take that out of the
Yeah, for some of you.
Yeah, I got it next
So
time.
last lesson for some of you before all the exams. Okay, the shape T, who's done a rotation question? Not many people looking around the room.
Me.
That's a lame excuse. You use tissue paper or use something which is easy to come back 180 degrees about the point 30 to give the shape U. So this shape is rotated about the point 30. So we use the shape, we connect it with a, what do we say this part here is called? The rod.
The rod. Oh, the rod.
The rod technique.
Yeah.
So we turn the whole thing 180 degrees. So this part here, this little line here, is now going to end up where? There. That was going up, now it will be going
Down.
down. So let's just redraw this shape. What do we get to this shape? Come on, folks. Let's have a look again. Who's done the shape? Ah, very nice. Yeah? So at the end of the bar, we're going to have the long piece. So how long is the long piece, Samir? How long does it go down for?
Till -4.
To -4. And then it goes back up to 6, is it?
6, yeah.
There you go. So then you got the shape U. So this is shape T. This is shape U. The shape U is rotated by 180 degrees about the point 60. So now they rotate the shape along that point there, 180 degrees. So where does it end up now, the shape? It ends up there. Mr. Mies, what are we doing? Okay. Mr. Mies, are we doing the question or are we doing something else? Okay, can we focus? Okay. So we've rotated this shape about this point all the way down to here. Then we rotated about that point up to here, another 180 degrees up to here. The question was describe fully the single transformation which maps shape T to shape V. T to V. How did this get to there? So the words that we use is?
Is it a translation?
We say it's a translation by translation vector or by vector. So it started off at 2 and it's gone to 8. So it's gone across by 6 and it hasn't gone up or down, so it's 6, 0. And that's the end of that question. I'll let you copy that down. I'm going to forward on to the next question. You all done?
Yep.
Mr. Harun, you got that down? Translation by translation vector. You need to have to go this stuff at home first, Mr. Harun, okay? And bring it and show me what you've done. Okay? Otherwise, it'll just be like just a copying exercise. You need to be learning this stuff and filling in the gaps where you don't know it, rather than just relying on the lesson itself. Okay, the interior angle of a regular, the key word is regular. Regular polygon is 160, write down the size of the exterior angle of the polygon. At the moment we don't know how many sides there are, we have to write down the size of the exterior angle. That's the easier part to do. So if this is 160, the exterior angle actually is here. What's that going to be? Homer?
20.
20. Why? Because 160 and 20 gives you 180. That's exterior angle. Work out the number of sides of the polygon. We know there's a connection between the external angles.
18.
So we have 360 degrees divided by the number of sides gives you the external angle.
18.
External angle is 20. So we can replace that with 20. So 360 divided by n equals 20. Now we do this thing called cross multiplying. Oh, you like saying so much. So the 20 comes down here and the n goes up there. That's cross multiplying. For those of you who want to know in the right place. So we have now 360 degrees divided by 20 is equal to n, the number size.
N equals 18.
So n, 360 divided by 20, knock off the zeros, 36 divided by 2 is 18. And the polygon has 18 sides. Done. Next question. Right. You all happy with that? Get that right. Okay, the cumulative question number 14. Big eye. The cumulative frequency diagram gives information about the time in minutes 80 people were kept waiting in a hospital casualty department. I'm quite sure they've got this graph wrong. Because normally when we go to wait in a hospital, nobody's waiting 10, 20, 30, 40, 50 minutes. You're normally waiting like,
Couple hours.
a couple of hours, maybe like 1 hour, 2 hours, 3 hours, 4 hours, and 5 hours. So I think this kind of very concerned. This is somebody's not telling us all the truth. What's happening in hospitals? Yeah, maybe it's a private hospital for. Right, let's get cracking on this question then. Right, question part A. Write down the number of people who waited for 20 minutes or less. 20 minutes or less. How many people? So what we do, we go to 20. I can't even tell them my 20 years in this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There. Okay, folks, can you please copy this as well on yours? So, for 20 minutes, I'm getting, it's coming up quite exact at 28. I'm getting 28 people. First we'll work an estimate for the number of people who waited for 20 minutes or less. 28. 26. Not 26, 28. And the mark scheme mark scheme gives you between 27 to 29. Okay. Okay, so next question. Work out an estimate for the number of people who waited between 26 minutes and 40 minutes. So 26 minutes and 40 minutes. Let's have a look. Different color? 20, 22, 24, 20. Was it 26? And what's the other time?
40.
40.
Yeah.
30 and 40. So for this one I'm getting 42. Did you get 42 for that?
Yeah.
That one's 42. And what's the other one for?
68.
Yeah.
And the question was work estimate for the number of people who waited for between these two. So it will be 68 taken by 42. 68 taken by 42 gives an answer of?
26.
26 people for that one. Okay, right. I'm gonna rub off now from the board these calculations. I'm going to do the next question. Don't get confused with the lines. Okay. Okay, let's just see if we can make this graph a little bit bigger. Little bit bigger. Yeah, that's good bigger. Maybe a little bit more bigger. I think. Yeah, I think that even that's nice as well. But I think we might need to go over just a teeny bit. Back down to that. Okay, we have to take that out at the moment. I think all of the graphs are a bit too much of a compromise.
So you
Okay.
2 minutes of recording.
Okay, we should finish this next question in the next 2 minutes. The hospitals target that no more than 15% of people are kept waiting for 40 minutes or more. 15% of people. How many people did we have coming to the hospital that day?
28.
How many people altogether?
80.
80 people. So we're going to work out 15% of 80 first of all, see what that should be. So we work out 10% first of all. 10% of 80 is 1/10, which gives us 8. 5% is half of 10%, which is 4. Half of that. So 15%
12.
is 12. So,
Yes.
okay, that we have to see they got not more than 40 minutes. So where's 40 minutes? Okay, 30, 1, 2, 3, 40. Let's have a quick look. We're using our ruler. I go to 40. Okay, I get here 68, and the total was altogether was 80. And 80 taken by 68 is 12. And did they hit the target? Exactly. So the answer is yes. Okay, so 15% of 80 is 12 people. No more than 12 people should be in this region here, waiting more than 40 minutes, which is over here, which is 12 people. So it's exactly on target, bang on target. So write a little kind of sentence for that. Okay, Ramiz, come on. Okay, this is now question, we've done that one. Question 14. Okay, some of my favorite questions here. Okay, question number 15a is simplify 4m squared times by 3m to the 5. So the 4 times by the 3 will give us
12.
and the m squared times by the m5 will give us
7.
right, 4 times by 3 is 12. When we multiply these two, because they're both the same at the bottom, we add the indices. Done.
1.
Anything to the power of 0 is equal to 1.
20.
Okay. Now, go simplify this. We have got now in here 1, 2, 3 items, all of them being raised to the power of 3. So, Mr. Umar, that's currently 2 to the power of 1, times by x to the power of 6, times by y to the power of minus 1.
It's not minus 6.
Is it 8x? What times it by?
It's not minus 6.
Look. Where?
Minus.
Say that again. Okay, are we happy with the 2 to the power of 1, x to the power of 6, and y to the power of minus 1? Now we have to raise all of these to the power of 3 on the outside. So we have time by 3, time by 3, time by 3. Okay, right. Now what do we get now? 1 times by 3 is
3.
3. 6 times by 3 is
18. And
minus 1 times by 3 is
minus 3.
minus 3. Okay, folks, are we happy with that? Okay, right.
So you're making noise.
Population of Algeria is 34 million. Write 34 million in standard form. We have 34 and we have how many zeros?
6.
6 zeros. We need the number to be. Afira, can we consider the question, please? It's not too difficult for you. 3.4 from here. 1, 2, 3, 4, 5, 6. How many jumps?
7.
None. Okay, next question. Okay, the total land area of Algeria is 2.4 times by 10 to 12 meters squared. 5% of the total land area is used to grow crops. Work at the area of land in Algeria which is used to, I can't see that part of the question, which is used to grow crops. Okay, so we got to work at 5% of that. Okay, so we have 2.4 times by 10 to the power of 12. Now, I need to work out 5%. So I'm going to use the technique where I work out 10% first. To work out 10%, we divide this by 10.
Yeah.
Okay? If you divide this by 10, what happens to the 12? It becomes a 11.
Oh, 11.
Why does it become 11? Because this is being multiplied by 10 12 times. So we're losing and we're going back about 1/10 because we're dividing by 10. So that's 10%. That's not my answer. I need to work out 5%. 5% is half of 10%. So half of this. So half of this, what do we actually halve here? The 2.4. 2.4 halved will give us 1.2 because the 10 to the power 11 doesn't get halved. Because if you think about it, if you got 2.4, say for example it's 2.4 million, if you half 2.4 million, the answer will be 1.2 million. You're not going to change the millions and turn it into like 100,000 or something. You're not change that at all. Just, that's the key thing here. Done. 1.2 times by 10 to the power 11.
Cross multiply this one.
Okay. Okay.
You have to change it to kilometre squared.
What have you got at the moment?
You just got standard form.
We got meter squared. I was just thinking that I haven't finished. So this is meter squared. And we need to change it into kilometre squared.
By 1,000.
Polygon. Okay. So let's have a look at a kilometre. So 1 kilometre by 1 kilometre. Okay? If you had more space. How many meters do you have in a kilometre?
1,000.
How many meters in a kilometre?
1,000.
So 1 kilometre squared is this times by that. What's 1,000 times by 1,000?
10,000. A mil.
A million. Okay? So 1 kilometre squared is equal to 1 million meters squared. So if you want to change these meters squared into kilometers squared, we have to divide it by a million. So we have to divide it by
Didn't that take off
another
0?
6 zeros. Yeah.
That's 1.2
Why does
times
it?
10 to
Now remember
the
this. This is 1.2.
No point.
Okay, this is 1.2 times by 10 to the 11. So how many zeros do we actually have on this? We don't have 11 zeros, by the way.
No, we don't.
We have
12.
10 zeros.
Oh shit.
Because you have to jump once over the 2 and then another 10 zeros. So we've got 10 zeros in the number and we're dividing at the bottom by a number that has 6 zeros. So the 10 zeros minus the 6 zeros of bottom left leaves you with
4 zeros.
and then you've got to add the 1 jump away, that's 5 altogether. Yeah?
Okay.
So the answer will now be 1.2 times by 10 to the power of 5. 1.2 times by 10 to the power of 5. And that is lovely. Let's look at one more question. Good. Right, that's lovely. That's nice big size there. The image is beautiful. Bismillah, let's get started. Okay, right, ladies. simplify fully this algebraic fraction, so we have to take it from two fractions into one fraction. What we need to do is find the lowest common multiple. Okay? So we have 4 and 3. What's the LCM of 4 and 3? 12. So we need to make the fractions into 12ths. 4 can become 12 by timesing by top and bottom. 3 can become 12 by multiplying by 4 top and bottom. Now let's rewrite it. So that gives you 3x plus 3 over 12 plus 4 lots of x minus 5 over 12. Now, when we do adding fractions, we never add the bottom numbers. We need the bottom numbers to be the same. Okay? Now, when the bottom numbers are the same, we can put one big line in the bottom number. So, when we add in 12s to 12s, the answer will be in 12. So, now we have to just add the top numbers. So, we can write that here. Okay, now what we need to do is multiply out the top part and then simplify it. So we have 3 times by x is 3 times by x is 3 times by plus 3 is plus 4 times by x is plus 4 times by minus 5 is all over 12. Let's simplify it now. 3x add 4x is equal to
7x.
9 take away 20 is equal to
Minus 11.
and that's the answer that we should have. Done? Whoa, question number 18. Nice and big. Okay. Let's just read the question for question number 18. Has anybody done this question? I see lots of empty pages as I walk around the class, lots of empty pages. Okay, anybody done this question? You ready to go? You done it? Okay. Alright, let's have a look. Okay, question number 18, let's read it. It says, diagram not accurately drawn, that means we're not allowed to measure the angles. Okay? A, B, C and D are points on the circumference. A, B, C and D are points on the circumference of a circle, center O. Angle AOC is 168. Work out the size of the angle ADC. ADC. We've got to work out the angle, which one? ADC.
What is it?
ADC. Got to work out the angle. Now straight away, when you look at that question there, we should have an idea how we're going to work that angle out. Now if you look at the shape here, which I'm going to go over in blue. Okay, what shape have I made in blue? Ignore everything else, just look at the blue shape. It's a quadrilateral. When you have a quadrilateral inside a circle, it's called a cyclic quadrilateral, not a kite. Okay, so we have a cyclic smear. My pens are all sorry.
What's acyclic mean?
Cyclic means it goes around in a cycle, it goes around all the way, touching. A cyclic quadrilateral in a circle. That's what we have there. So what do we say? We say opposite. So opposite angles of a opposite angles of a cyclic quadrilateral add up to
80 degrees.
180. Okay. So we know that this angle and this angle here. Okay. So we know that angle, was it CBA? So angle CBA add angle ADC, which is the one we want. Both of them add up to 180 degrees. Okay? Are we happy with that, ladies? So this angle and this angle are labeled as CBA. Or we can just do it as ABC. ABC. Okay, now that is what how we found that angle. Now, what do we know? How do we work at this angle knowing this one?
Minus.
These two, how they rated? Okay, how are these two rated?
Opposites.
No,
No,
that one
no.
is smaller. That's
That's
This one,
Half. It's half.
The
this one's
angle-
double of
That one.
that one, yeah, so this one's half, yeah? So we can say here angle,
These two.
Something to do with the triangle.
okay,
Oh,
so
no.
angle subtended
That was it.
at the center is double that subtended at the circumference. So the angle subtended from the here's the arc here. That's an arc, and that's the angle that comes from the center, and that's the same one for the same one, yeah? So the angle subtended from an arc at the center is double that subtended at the circumference. So this angle is double of that angle. Okay, ladies, let me write this down. RE, which one is it? A or C? AOC is equal to double of ABC. So this angle here is double of that one. So that one is obviously half of that. Therefore, angle ABC is equal to what? 80. What's it equal to? 84. Yeah? So these two here, this one is double of that one. So that makes this half of that, which is 84. Now that we know this one, we can work out that one. What is this angle here now? What is it? 84. So I said here, I made a statement, ABC at ADC is 180, so I'm going to rub this one out now. I'm going to put in here 84. 84 at this angle is 180. Therefore, ADC is opposite, add 84 is minus 84. So 180 minus 84 will give us, so angle ADC will give us an answer of
96.
96. Strange. Okay. Are we happy with that, folks, on the explanation?
Let's stop here, sir. Here's a 5 minutes break.
So hold on.
As I promised before, you got a 7-day break to the next lesson. That's a really long break. Let's try to do as many questions as possible, taking into consideration you have an exam next week.
So I got 1 2 minutes.
Yeah, mine's.
We have to zoom out a couple of times.
Okay, here we go. The next question, I think we should be able to fit in this question quite easily before the time that you got a break. Question number 19. Martin and Luke are students in the same maths class. The probability that Martin will bring a calculator to a lesson is 0.6.
0.8.
Pardon me, 0.8. And the probability that Luke will bring it to the class is 0.6. Complete the probability tree diagram. These are independent events. 0.8 is the one he'll bring it, so the one he won't bring it will be
0.2.
0.2 because they got to add up to 1. Luke's 0.6, so the opposite of 0.6 is 0.4, 0.6, and 0.4. So that's that part of the diagram done. Look at the probability that both Martin and Luke will not bring a calculator to lesson, will not bring a calculator.
0.8.
So that means you've got to go down here, not bring calculator, and probability of no calculator and the probability of no calculator. Okay folks, right. Okay, remember the camera there picks up all the sounds around the room. Yeah? Probability of no calculator is going to be for the first person, Martin was 0.2. And means? And the probability of no calculator for the second person, Luke, was 0.4. So 0.2 times by 0.4 will give us 0.08. Okay, I think we have enough time to do one more question quickly.
Yeah, I think we got 7 minutes.
Yeah, 7 minutes, yeah, sure. One last question, folks, before you guys disappear. Nice and big. Solve the simultaneous equations. Okay, Mr. Ramiz, are we getting good picture on there, please? Can you check?
Brilliant.
Nice and clear? Solve the simultaneous equations. It was nice and so big. I think anyone will see that. Now, what we need to do in simultaneous equations, Umar, is we need to make either the x equal to themselves, equal or opposite. Yeah. Or the y equal to themselves or opposite. Yeah. So if you look over here at the moment, the x coefficient is 3 and 2. The y coefficient is plus 2 and minus 5. So which one would you like to eliminate?
Y.
Excellent choice. So we're going to choose the y's. Let's look at those coefficients. I need to make this plus 2 and same as minus 5. What do we do? Times the top one by the bottom number and times the bottom one by the top number. Excellent. So 3x times by 5 is 15x. Plus 2y times by 5 is
10y.
Plus 10y. 11 times by 5 is
55.
Equation number 1.1. This bottom equation, we're going to multiply all of it by 2. We're going to double the whole lot. So 2x times by 2 is 4x. Minus 5y times by 2 is minus 10y. 20 times by 2 is 40. This is equation 2.1. Okay, ladies at the back. Is everybody write this down?
Yeah.
You done it? Okay, has she done it? Okay, are we doing it?
Yeah.
Okay, those of you who haven't done it yet, can you please make sure that you're doing it? Okay, you can save your daydreaming for when you get home. Okay, now, let's have a look at this. Now that is very nice. We have the coefficients. The coefficients of y is plus 10 and minus 10. We say these coefficients are opposite to each other. So when the coefficients are opposite doesn't mean just a different sign, opposite sign. It means they're actually opposite. Opposite of plus 10 is minus 10. Opposite of plus 5 is minus 5, like that. If they're opposite to each other, if you want to eliminate the y coefficients, what do we do? Add them. If you add opposite things together, give you nothing. 15x add 4x will give us
19x.
19x. 10y add minus 10y gives you fresh air. Nothing. 0. 55 add 40 will give us 95. So now we've got to work out the value of x. So x has been timed by 19. So opposite timed by 19 is divide by 19. So x gives us a value of 5. Now that we know the value of x is equal to 5, we can substitute it back into any one of these equations to work out the value of y. So I'm going to put it back into the first one. We have 3x add 2y is equal to 11. So we'll put this x value 5 into here. Okay, remember it doesn't become 35. It's not 35, it's 3 times by 5. Add 2y is equal to 11. So 3 times by 5 will give us 15. Add 2y is equal to 11. We need to work out the value of y, so we have to make y the subject. Y is being timed by 2 first action and added by 15 the second action. Opposite add 15 is 11 take with 15 is
minus 4.
So 2y is equal to minus 4. Do not freak out if you see a minus number in the calculation. We are doing mathematics. We do have minus numbers in mathematics. Most students see that and stop. Opposite time by 2 is? So y is equal to minus 4 divided by 2, which gives us an answer of?
Minus 2.
So y is equal to minus 2. So x was equal to 5, y is equal to minus 2, and that's a good place for us to stop here. Okay, bismillah. Right, question number 21. We have simplified 3x squared minus 16x. Okay, minus 35 divided by 9x squared minus 25. What we need to do in this particular question is consider the top as one question, the bottom as one question. So now let's have a look at it. Let's have a look at this question over here. So we have 3x squared minus, minus 16x minus 35. Now, in this particular type of question, we can see here the a value is not 1, it is 3. So we need to split up 3x squared into its factors. So let's split it up. So 3x squared can only be split up in one way because 3 is a prime number. So it will be 3x and x. When we multiply these two brackets here, these two here, it will reconstruct the 3x squared. Now we're looking for two numbers that multiply to give you minus 35. So we got the usual one, minus 1 and plus 35. We have plus 1 and minus 35. Okay, this is our little kind of working out. And we have minus 5 times by plus 7. We also have plus 5 times by minus 7. Now, looking at that, we need to get minus 16x. When we simplify it, we can see straight away that these particular one factors up here, these are not necessary. These are too big, so we won't be considering them. So the ones that we are interested in now in this question is, we are interested in these ones here. So we are interested in these ones to see which one fits the bill. Now, let's just change to black now. We need to put in here, in these two positions here, the right set. We need to put the right set of, the right pairs of numbers, and also the right position as well. So for example, we need to get minus 16. If you put in the minus 7 opposite the 3x, minus 7, we'll have to put the plus 5 in the other space. Plus 5. Okay, now if we multiply this out, let's have a quick go. That gives you 3x squared, which is tick. That gives you minus 21x, which you might say, oh, that's wrong. Why is it minus 21? You only got minus 16. When you add the 5x, that gives you back to minus 16. And when you multiply these two, it gives you minus 35. So that's done. That's the top part done. Now we need to consider the bottom part. So now let's consider the bottom part of the question. Okay. So we got here now 9x squared. We got 9x squared minus 25. Now this type of question here, this is called the difference of two squares, because 9 is really 3 squared x squared. You go here. Take away, and 25 is really 5 squared in disguise. Now if I want to simplify this, make it look a bit more manageable, you could write as 3x all of it squared minus 5 squared. Okay, minus 5 squared. Minus 5 squared. Now when you factorize, when you put these into factors, we have a template, a special way that we put them in. So we copy this down first of all. We copy down 3x here. Copy all that down. Okay, we copy down the minus. We copy down the 5 from here. We now repeat this bracket on the other side with one difference. The minus, that was a minus, it now becomes a plus. Okay, this technique is called the difference of two squares. Difference means minus is a square number, which is 3x squared. 25 is 5 squared. This is how we factorize these particular type of questions. Now, let's get back to the original question over here. Now that we factorized this and we factorized this, we can put it all back together again. So this here, 3x squared, is represented by this line here. So let's copy it down. So we have 3x plus 5 x minus 7 on the top. So you replace this part with this part is equivalent. Now the bottom part here we said is equal to this. So let's copy down the bottom. 3x minus 5. Okay, and then we have a 3x plus 5. Okay, now that we got that, you should be able to see quite nicely that 3x plus 5 and 3x plus 5, they match. So we have 3x plus 5 times by x minus 7 divided by 3x minus 5 times by that. So we can cancel these two. So we are now going to be left with x minus 7 on the top, x minus 7 on the top, divided by 3x minus 5 on the bottom. And that is the end of that particular question. Okay, folks, that is the answer. Okay, thank you very much for joining me on this question. Okay, let's stop. Okay, Bismillah. Okay, question number 22. Mr. Walton is responsible for maintaining fish stocks in a river. The table gives some information about the length in centimeters. Okay, let's get that. In centimeters of a type of fish caught from the river. Length, frequency. Okay, he wants to study the fact of returning to the river fish less than 50 centimeter length that are caught. Okay, right. Because Mr. Walton suggests, okay, the part that you can't see the moment, Mr. Walton suggests that fish which are less than 50 centimeters length are returned to the river. Draw a suitable statistical diagram for the information in the table. So that part is below this, okay, over here. So I've read that part to you. What we need to do now is, we can do here cumulative frequency, histogram, frequency polygon. I'm going to choose to do a cumulative frequency graph. So I feel that'll be probably one of the easier options here. Here we go. Right, let's just make a small part of the table. So we've got a rectangle here. And let's go for a blue one. Okay, right. Okay, right, let's do some more. Okay, so we have, okay. Okay, so I'm just going to put some little boxes here. So I can the frequency. Okay, folks. Yeah, I'm doing it. Okay, right. What we're going to do in here, in this box over here is, we're going to do the cumulative frequency. Okay, right, let's change to a big CF for cumulative frequency. So what we do when you do cumulative frequency, we need to look at the first number here that goes across. 40 is the first total. Remember, cumulative frequency means running total. So now we have to add the 60. So 40 add 60 will give you 100. And then you have to add the next number, put that in here. So 100 add 90 will give you 190. Okay, then we have to do 90 add the 60, that goes over here. So 90 add 60 is, that'll give you 250. And the last total we have to do 250 add the 0. Okay, that'll give you 250 still. Okay, now, the next part of the question, the graph which is provided by this examination is, I find it impossible to use, so I'll be overlaying my own small piece of graph paper. I will show you, so you have your confidence. Right, let's just show you. Okay, so I'll get that down. Oh, let's clear that. So as you can see from this particular type of graph, I think there's some printing errors. Half the spaces are missed out. The lines on the side is very difficult to actually draw on this. So I'm going to be overlaying my own one. So let's try that now. So let's just put that graph that I'm going to use. Okay, right. Okay, all right. Okay, right, give me 1 second, folks. There's... Right. Right, okay. So I'm going to use this particular graph as a substitute for the one that the examiners provided because it was just rubbish basically. Can't even use it. Right, let's have a go at this question now. Okay, we've actually lost all our data. That would have been nice if we could actually see it now. Okay. Right, okay, I've got a copy of it over here. Alright. Alright, let's get that back up. Right, let's move this across. Okay. Right, okay, right, let's just quickly write those values back in. So we had a cumulative frequency over here, just from the previous part of the question. It was 40, it was 100. Okay, sorry about this, folks, it's just 250. And 250 was the results. Okay, so this one was here, was 40. Now, what we're going to do on this particular graph over here, we're going to draw on here our lines, so our scale. So let's put a line on there. Let's choose a black line, so start from the bottom. Okay, so we're going to do another black line here. Okay, sorry about the slight distortion on the black line. Right, let's get back to annotation. Get some numbers down, scale. So we can say this one here would be our 0. Okay, and this one here will be our 20. We have to go up in 20s to cover the scale, which we've got to go from here, which is the frequency, sorry, the length is up to 80, 20. Okay, we got 20, then we got 40. Okay, I'm improvising here, folks, so please, forgive any mistakes that we make here. Hopefully no mistakes. Okay, right. That's the bottom scale. So the bottom scale is the length. Length in centimeters. Okay. Now this vertical axis here will always be your cumulative frequency. So that will be your cumulative frequency. Okay. And we're going to go now, we need to go from up to 250. So here we have to go up in 50s. So that's 50. And that's going to be 100. And that should be 150. And that one should be 200. And the last one over here should be 250. Okay, this graph here looks much more better than the one that we've been given over here, because this graph over here is a no-go. And I'm saying that as a maths teacher that I've never seen anything like this in my life. Okay, right, so let's get cracking with some of the plotting points now. So we're still annotating. Let's get some points in that green. Right, so we know now when we do cumulative frequency, we always plot on your class with the boundary points to the end. That will be your x values. Okay, and the cumulative frequency will be the corresponding y values. So we have to go across by 10 and up by 40. So across by 10 and up by 40, so it's going to be 5 squares across and up by, so let's have a look at the scale we got here. We got 10 little squares is equal to 50. Okay, so if you want one little square up will be what? 5. So we need 40, we go up by 8 squares. So across by 5 and up by 8. So 1, 2, 3, 4, 5, and then up by 8, it should be there. Okay, that looks bang on. The next one here, so we've done the first one. We've plotted, okay, we plotted the 40. Okay, let's do, so we just plotted the 10 along with the 40. We've done that. Now the next is going to be 20 with 100. That's the next one. So we have to do 20, 100. Okay. Okay. 20 is over here. And up by 100 is a nice one. That one's going to be here. Lovely. Okay, let's get the next set of coordinates. Okay, next set of coordinates is going to be 40 along the x. Okay, whoa, that's a horrible color. And 190 along the y. 40 and 190. So let's change back to our green. So 40 and up by 190. So 190 is going to be 2 squares less. 180, 190, yeah. Done. 190. So each 2 squares up is worth 10. So 160. So 190 will be 2 squares below that. So next one now. Okay, let's choose the turquoise again. And we're going to go for the next points 80 and 250. So back to 80 and 250. So we're going to go cross by. Okay. Okay, so they haven't done 60, they want 80. So 80, go up, and we're going to go to 250. 10, 20, 40, 80. 10, 20, 40, we've done 40, the next one is 80. 80 is going to be 250, which is right at the top. Okay, lovely. What I'm going to do now, I'm going to put little circles around them to show you where they are. Let's do them in black, so we have an idea, because they're a little bit difficult to see at the moment. I didn't want to mess them up. So we have here, here's our first point, here's our second point. This is just for me to indicate for you. Please don't repeat this in examination. Just for me to indicate to you what we're doing. So them are the points we're going to do. Okay, we don't need to do any more really, more than 80, that's it. Now we need to join them up. Okay folks, this next part of the question, join these points up freehand using the equipment I have is going to be very difficult. I don't have any curve drawing tools. Do we? Ellipse. Okay, I don't know whether this is going to help us. Let's have a look. No, not really. Okay, right. I think we just have to do freehand. Folks, you have to be very patient with me regarding this one. I don't know. I'm going to try my best to do it. Okay, here we go. Here comes the graph. And this is going to be very difficult. Okay, folks, it's going. And we are now recording this session. Okay, right. So I've got this particular kind of graph at the moment. I've got this kind of graph. Okay, sorry about that, folks. I haven't mastered the art of this at the moment. So the question says here, Mr. Walter suggests that the fish which are less than 50 centimeters in length are returned to the river, less than 50. So let's have a look. Right, okay. So we go for a line, and we're gonna go for a green line. So we're looking for 50, and we're gonna go up to the graph and go across. So we have 1, 2, 3, 4, 5, which is here. Okay, now, taking consideration the reference of the line, I'm going to have to use a solution that I've done on the paper as well. So, we're going to do another line here, from here roughly. Right, you're going to go across. Okay. Right, now, I'm going to use the solution that I've used earlier. I've done this paper. Okay, just give me one moment, folks, while I get that.
It's in front of you. Okay.
Okay, right. According to a graph that I done earlier, this line should be round about the 2, even though it's higher here, it should be round about the 205, 210 mark. That's when I've done it on a piece of paper. So, okay, let's write that on there. Okay, red. So, this number here is meant to be approximately 210. Okay, so now what we can do, it says less than 50 centimeters. So all this data here, which corresponds to all this data over here. So we do the calculation. 210 fish are less than 50 centimeters. So divide that by the total of number of fish that we have, which is 250, and then we multiply that by 100 to work out what percentage that is, and that will cancel down and give us an answer of 84% as our final answer. Okay, so find the estimate of the percentage of fish returned to the river. That's the answer. And the mark scheme allows us answers. The mark scheme is giving us answers. So the examiner knows that everybody's graphs is not going to be exactly the same. There'll be some slight discrepancies. So they're giving us an allowance of 80 to 85%. Any answer within that region is counted as correct. So we are inside that region there. So that's our final answer, 84%. Okay, that's the end of this question. Folks, thank you very much for being patient with me, just with this particular technology, using it. Okay. Okay, Bismillah. Question number 23. Express the recurring decimal. Okay. Recurring decimal 0.213 as a fraction. The part that's recurring is this part only. The 1 and the 3. So these dots here indicate, so anything between the dots is recurring. The 2 is not recurring. So let's start off this question. So we say, first of all, let x equal to 0.213. Remember, this part recurs only, so the next part is going to be 1, 3, and then 1, 3, and so on. Okay? Now, what we need to do, we need to get this decimal number in such a way after we multiply by 10, 100, 1,000, so that these numbers line up over here, and we can minus it and left with the whole number. So let's have a look what 10x gives us. So we do 10x. 10x is equal to, if you multiply this number by 10, we get 2.1313131, and so on, and so on, and so on. Now, as you can see here, these numbers here, these numbers here do not match. 2's and the 1's are not good. These numbers need to be identical here in these columns. They don't match up. So let's try 100x. So 100x will give us 21.3131313. And as you can see here again, 2 and the 1 and 3 they are not identical numbers. So this is the next column, they're not matching up, so that they won't help us. We try one more, and this should give us what we're looking for. So 1000x, if we multiply this number by 1000, we get now 213 points, so 213.1313131. And now we are in good luck. So we can have a look at this now. We look at the turquoise color. So if you look over here now carefully, so this one lines up with this one. Okay? This one lines up with this one. This one lines up with this one, and so on and so on. So let's have a look what else matches. So if you go to pink, so this 3, okay, this 3 lines up with this 3 over here. This 3 lines up with this 3 over here. The alignment is important. The numbers must line up. So when we minus them, so we are now interested in this one here, 1000x and 10x, because this numbers after this point all match up. So what we're going to do now is we're going to minus them. So we're going to do now, we're going to look at this 1000x. We're going to say 1000x. 1000x we have to minus this 10x. So 1000x minus 10x will give us a total of 990x. Okay, 90x. Okay. Right. Now, similarly, 1000x is that, and that is what 10x is. We have minus them. So this number, take away that number, will leave you with, so this part here will cancel. Complete that how you minus it. So we're left with now 213 minus the 2. So 213 minus 2 will give you what? 211. So now one more final step of rearrangement. So we get to here, okay, opposite of multiplying by 990 is to divide it on the other side. So x is equal to 211 divided by 990, and that is the final answer. Okay folks, I hope this helped. If you're stuck on these questions, always refer back to my recurring decimals other video on my YouTube channel, and that should hopefully help you. Okay, thank you. Okay, bismillah. Okay folks, this is take 2 of question number 24. Take 1, you lost the audio. Okay, let's get a highlighter. Okay, a cylinder, which is this shape here, has a base radius of x and a height of 2x. A cone, which is this shape over here, like an upside down ice cream cone, has a radius of x centimeters and a height of h. Now the question is talking about the volume of the cylinder and the volume of the cone are equal. So the volume of the cylinder is equal to the volume of the cone. Okay, lovely. Because they find h in terms of x. So that means if they want something at the end of the equation that says h equals, and a formula with x and answer on this. Well, give your answer in the simplest form. So let's have a look. Let's change to a normal pen. Now let's look at the formula for the volume of a cylinder. So the volume of the cylinder, we know, is equal to the volume of the cone. The volume of a cylinder, if you turn to the front page of your examination, it will give you the formula as pi r squared times by the height. And the volume of the cone is going to be given by 1/3 times by pi times by the radius squared times by the height. Okay, so that's the volume of the cylinder and that's the volume of the cone. What we need to do now, we need to substitute in there the values for radius, values for the height, radius and height. Now the radius of the cylinder is here, is x. So we got pi multiplied by x squared multiplied by the height. Height is over here, the height of the cylinder is 2x. And that is equal to, okay, let's change that a bit. Equal to, okay, let's go back to green. It says 1/3 times by the pi times by the radius is still x, so it's x squared times by height. The height actually is just h. So what we need is, we need to work out this, the height. So we need to get rid of all this simplified row. So let's have a look how we can do that. So let's change to a red. Now we need to simplify, so what we can do first was cancel. You have the left hand side and the right hand side. So if you start simplifying, if you divide left hand side by x squared, I have to divide the right hand side by x squared, they cancel each other out. If I divide this left hand side by pi, divide the right hand side by pi, they cancel each other out. So now what we're left with is 2x equals 1/3 h. Now I need to get h on its own, and the opposite of divided by 3 is time by 3. So that comes to this side, that comes a time by 3. So we have 2x times by 3, that gives you 6x. And then we have 1 time by h, which is just h. And we have finished the question amazingly. I hope the sound is working for this question now when I check it. So that is the answer for the h. Don't worry that the h is written on the right hand side and it's not on the left hand side as traditional questions. It can be inside, it means the same, it doesn't matter. Okay folks, thank you for joining me on this question. I hope this helps you with the examination preparation. Okay, bismillah. Question number 25. Okay folks, we come to the end of the paper now. Right, let's looking at the graph of y is equal to f of x. Now f of x is a generic term used to describe a function. If f of x can be, depending on the question, could be a straight line function, a quadratic function, a cubic function, a sine function, cosine function. But in this particular case, it represents a quadratic function, as you can see. It's shown on the grid. On the grid, sketch the graph of y is equal to f of x. Now, let's change the highlighter. Okay, now, here's our original function, f of x, which is the same as that one over here. But if you look, the only difference here is the minus 4. Now the minus 4 has been done after the function has been calculated. So the minus 4 indicates that the whole graph has to be moved down by 4 places. And that is as simple as we can get this question to be. So we need to literally get each point and move it down by 4. So let's have a go over here and right. So if I look at if I look at main points, so we have one point here, we have a point here, and we have a point here. So I'm considering some points of the graph. Okay, we have this point here. Right, what we're going to be doing is dragging these points 4 places down. So let's change the color of the highlighter. So 4 take away 4 will give you nothing. 0, this has a height of 0. 0 take away 4 is minus 4. 0 take away 4 is minus 4. Now, I don't know, this one take away minus 4 will be down here somewhere. Okay, I don't know where this is actually coming up. Right, let's just choose a different point. Okay, you get my flow, otherwise I'll have to move the whole graph up. Don't want to mess that up now. Okay, I'm just going to choose a different green point. I'm going to leave those points there. Right, let's go for turquoise again. Right, I'm not going to look at these values here anymore. Let's look at this one here, this one, and that one. Let's rub off the other ones. Okay, let's rub them off. Okay, let's change back the highlighter. Back to a pink. So what we've done now, we're going to move this point, which is at minus 10 height, another down by another 4. So it'll be here, minus 14. This point here, that minus 10 is the height, it comes down by 4 points, so that'll be minus 14 as well. Now we should be able to draw a curve. Now, okay folks, apologies in advance, I haven't had much training on this new equipment that I've got for drawing this stuff, this special pen and pad, so my graphs are going to be extremely wonky. Apologies folks in advance for the just lack of fluidity in terms of drawing curves and stuff on this equipment, but we need to basically draw from here to here. Oh gosh, this is going to be, I don't even know how I'm going to try this. I think what we can do is draw lots of dots and join them up. You'll get the idea of what I'm trying to say. Okay, right. Okay. Okay, right. So we're gonna have. Right, what I'm going to do now, folks, I apologize. Like I said, I've just literally bought this equipment. In the last, I'm not very familiar, and it takes a lot of training and expertise. I'm just trying my best now to kind of sketch. So this black line here, the original graph, will go onto the pink. If you just join this up yourself, please, and that is where the graph will move down to. It will move down by 4 in each place. Okay, sorry about that, folks. Right, let's clear this page and move on to the last part of the question. Okay, for this next part of the graph, we have y equals f of half x. What that tends to do is tend to stretch the graph out and make it more wider. Okay, so now the 4 point, again I'm going to do with the 4. Now f of 0 is equal to 4. Now if you put half in the same place, half of 0 is still 0. So that value there actually won't change. It won't be changed by this changing by putting half inside the function. Now what will change is the place that was really at minus 2 will now move out to minus 4. What was that? 2 will move to plus 4. Like that. And this point here that was at minus 4 will move out to minus 8 to double it. Okay, and same on this side. So if I want to, I'm going to draw the curve by just doing lots of dots because I'm having quite a bit of difficulty actually drawing curves on this equipment. So you'll have to kind of join up yourself. Okay. Apologies, please. Okay, folks, sorry about that. Okay, so your graph will get wider if you put the half inside the function. Okay, folks, that's the end of the examination paper. Work hard. Should be uploaded by as soon as possible, so get it edited and joined together. And it should be ready for you for Sunday, which is already Sunday now already. So Sunday the 8th of June, folks. Please practice it, look at it, and pass this exam. That's coming ahead on Monday.